Hello students, myself Dr. Amol Rahane welcomes you to the course Physics Principles and Applications for FYBSc Semester 1st Physics Paper 2 as per the revised syllabus of Savitribai Phule, Pune University CBCS 2019 pattern. So, in the previous lecture, we have studied different bonding mechanisms, what is meant by a chemical bond. We have also studied the forces between two atoms. When two atoms they come closer, what are the forces and what is the potential energy, right? So, we have also studied the potential energy curve, right? We have also calculated or we have derived the expression for internuclear separation between the two atoms, that means R equilibrium, right? So, we are studying the third chapter physics of molecules. In the today's lectures we are going to study different types of bonds, and here we are also going to study the ionic bond in detail. So, we know that bonding means attractions between atoms or ions, right? So, there are several types of chemical bonds, namely the ionic bond, covalent bond, van der Waals or molecular bond, hydrogen bond and metallic bond, right? Let us now study the ionic bond in detail. An ionic bond is a type of chemical bond which form through an electrostatic attraction between a positive ion and a negative ion, right? So, there are two ions, one is positive ion and another one is negative ion, and there is electrostatic attraction, right? We know that in electrostatics we have let us say we have a positive charge and negative charge. These two charges they attract each other. Similarly, here in the chemical bond we have the electrostatic attraction between a positive ion and a negative ion, right? So, what is the ionic bond? So, bond between oppositely charged ions, so involving a total transfer of electrons between the atoms. Here the bond is formed between two oppositely charged ions, one is positively charged, another one is negatively charged, and the bond also involve a total transfer of electrons between the atoms, right? So, a total transfer of electron from one atom to another atom, that will form a ionic bond. So, what is meant by an ion? Ion means a charged particle. That means if I remove one atom from one atom, if I remove one electron, so it will become a positively charged ion, right? If I add one electron to a neutral atom, one electron to the neutral atom, in that case it will have an excess electron, and therefore it will be a negatively charged particle or negatively charged ion or negative ion, we can say. And cations, we give names to them, the cations and anions. So, cations means which lose electrons and become positively charged. So, positively charged ion is called as cation, whereas anion means which gain electron and become negatively charged, right? So, cation, you should remember the cation which loses electron and become positively charged. So, if it is positively charged, that means it has loosened one electron or more than one electron, it become a cation, whereas an anion means which has gained an electron and it became negatively charged, right? So, anion means a negatively charged ion which has gained excess electron, right? So, in the ionic bond the cations they bond to anions, right? So, one atom gain an electron and one atom loses an electron, because the cation bonds with the anion, that means the one atom, that means the anion gains electrons and one atom loses an electron, that means the cation they loses the electron and they become positively charged, whereas the anions they gain electron and they become negatively charged. Now oppositely charged ions are attracted to each other due to electrostatic attraction, right? These two oppositely charged ions form they attract each other due to the electrostatic attraction, right? So the opposite charges attract that we know in the electrostatics, right? So mainly form in inorganic compounds like NaCl or KOH, etc., right? So this ionic bond is mainly formed in inorganic compounds like sodium chloride, that means salt, common salt, KOH, etc. Very strong bond between two different atoms. So it is a very strong bond between two different atoms. One has low ionization potential IP and the other has high electron affinity. That means we can have the low ionization potential. That means the cation which loses an electron, that means its ionization potential is very low. Ionization potential means the energy required to remove an electron from the atom and to make it cation or to make it positive ion, right? So it is the energy, ionization potential is the energy required to remove an electron from the atom, and if the energy required to remove an electron from the atom is low, then it can easily become positively charged ion or cation, right? Similarly, the other atom, that means the anion, has high electron affinity. So now electron affinity means the ability of the atom to attract this electron pair, or let us say the electron towards it, right? So when the other atom which has high electron affinity, that means it has strong ability to attract the electron towards it, right? Even though it has let us say the atom it is gaining an excess electron, but it has strong electron affinity, and because of that it will attract the electron, and in that case a very strong bond is formed, right? And therefore this ionic bond is stronger bond among all other bonds, right? So ionic bonds usually are formed by bonding between metals and non-metals, right? So metals, they lose electrons to form cations, and non-metal gains electrons to form anions, right? So the metals, they lose electrons to form cations, and non-metals, they gain electrons to form anions. So in the case of sodium chloride or NaCl, what we have is sodium is the cation, that means it is a metal atom, and chlorine is, we know that it is a non-metal, and it easily gain electron, so it form an anion, right? So the electronegativity between the metal and non-metal must be greater than 2, right? Electronegativity, that means each atom has the ability to attract electron, that is electron affinity. So this electron negativity must be less than 2, should be greater than 2. The difference between the electronegativities of each atom has electronegativity, and that value for metal and non-metal, so that difference, if it is greater than 2, in that case a strong ionic bond can be formed, right? Ionic bond results from positive to negative attraction, right? So positive and negative charges, they attract each other. So larger charge, the stronger attraction. So when the charges are larger, that means let us say 2 or more atoms, they are transferred from one atom to another, then it is a stronger attraction. And if the ion is smaller, again the attraction will be stronger, right? So in the case of smaller ions, again the attraction will be stronger. Now let us consider the formation of NaCl molecule or sodium chloride molecule. So we know that the electronic configuration of sodium, so sodium has 11 electrons, so its electronic configuration is 1s2, 2s2, 2p6 and 3s1. So we can say in the outermost shell it has only one electron, right? So in the third shell it has only one electron, and it can easily lose that one electron because its ionization potential is also very low. Whereas in the case of chlorine, it has 17 electrons, so its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5, right. So in the outermost shell we can see for chlorine we have 2 plus 5, that means 7 electrons, right. And in order to complete its octet configuration, it has to gain 1 electron, right. Here if this atom sodium, if it loses 1 electron, it can easily achieve the octet configuration, right. So in that case its outermost shell will be 2p when the sodium ion is formed, 2 second shell, and in that case 2 plus 6, that means 8 electrons it will be having, right. In the case of chlorine, if it get 1 electron, then it will complete the octet configuration, that means its outermost shell will have 2 plus 6, that means 8 electrons, right. So chlorine ion, when the chlorine ion is formed, it will achieve the octet configuration, right. So sodium has only one valence electron in its outermost 3s suborbit, which is it can easily lose, whereas this Cl has 7 valence electrons and is ever ready to accept 1 electron to complete its 3p suborbit, right. So it will get 1 electron, its 3p suborbit will be complete and it will attain the octet configuration, right. When the sodium atom loses 1 electron, it becomes positive ion, that is cation, and Cl gains 1 electron, that it becomes a negative ion, that is anion. So sodium atom, when it loses 1 electron, it becomes sodium plus, so Na plus, so it is sodium ion, or we can say cation. Whereas chlorine atom, it has 7 electrons in the outermost shell, so it is easy for it to get 1 electron. So if it get 1 electron, it will complete the octet configuration and it can have the 8 electrons in the outermost shell, right. And therefore chlorine ion will be formed. Since this atom chlorine ion will have excess electron, so it is negative ion, right. It becomes negative ion and it is called as anion, right. The two ions attract each other with Coulombic forces, which lead to formation of an electrovalent or ionic bond between the two neighboring Na and Cl atoms, right. So this Na atom plus Cl atom, when they come closer, the sodium plus, that means sodium ion will form and chlorine ion will form, and they will be attracted by strong force, right. It is because one electron is completely transferred from sodium to chlorine, right. At the same time, the two ions achieve noble gas configurations, right. That means they have their shells filled, right. Sodium will have its shell filled and chlorine will have its outermost shell filled, right. So win-win situation for both the atoms, right. For example, sodium plus achieve neon structure, right. So if we lose 1 electron, it will achieve the neon structure, so it will achieve the 2-8 configuration, whereas chlorine ion will get 1 electron, so it will achieve the argon structure, right. So 2-8-8, right. So it will achieve the noble gas configuration, right, when the bond is formed between the two atoms. In general, the formation of an ionic compound, a positive ion A plus, combines with a negative ion B minus to give a molecule AB, right. When atoms form an ionic compound, their electrons are shifted to the other atoms, but the overall number of protons and electrons of the combined atom remain equal and unchanged. Therefore, the compound is neutral, right. So when the ionic bond is formed, their electrons are shifted from one atom to other atom, right. So here from sodium 1 electron is transferred to chlorine, but overall number of protons and electrons of the combined atom, that means the molecule that is remain equal and it is unchanged, right? So the total number of atoms, they are unchanged, and therefore the compound is neutral. So sodium chloride is neutral compound. So let us see here in the diagram. So here we have the sodium atom. So sodium atom, it has 11 electrons. So it has electronic configuration, and let us say it has this 2, 8 and 1 electrons in the different shells. So innermost shell, it has 2 electrons, then second shell it will have 8 electrons, and in the outermost shell it has only 1 electron, right? So this 1 electron is loosely bound to the atom and it can be easily removed, right? Whereas in the case of chlorine, it has 17 electrons, so it has this 2, 8, 7 configuration, right? So if it get 1 electron, then it can achieve the 2, 8, 8 configuration, right? So innermost shell has 2 electrons, then the second shell has 8 electrons, and the outermost shell has 7 electrons. It is easier for it to get 1 electron than losing 7 electrons, right? So in order to achieve, it can either get 1 electron or it can lose the 7 electrons, but which is the easier way? So easiest way is to gain 1 electron. So here we can say it is there is electron vacancy, or we can say 1 electron is absent in this atom, right? So vacancy. So now when the sodium atom and chlorine atom, they come closer, so in that case what we have is transfer of 1 electron from sodium atom to the chlorine atom, and therefore the sodium atom becomes sodium plus ion, right? So it has lose, or it has donated 1 electron to the chlorine ion, and it has attained the 288 configuration, 28 configuration, that means neon gas configuration. Whereas in the chlorine atom has gained 1 electron, so therefore it has attained the Cl minus ion, or we can say it has attained the argon configuration, or 288 configuration, right? So when the NaCl molecule is formed, so in this case this is sodium plus ion and this is chlorine minus ion, they come closer and the NaCl molecule is formed between them. So this is the example of sodium chloride molecule, right? Now let us study the properties of ionic bonds. The ionic bond is the strongest among all the other types of bonds. The cohesive energy is about 5 to 10 electron volt, right? So the energy is in the range of 5 to 10 electron volt, and it is the strongest bond. So cohesive energy means the energy of formation of the bond, right? It is the energy of formation. That means that much of amount of energy we need to supply externally in order to break the bond, or that much amount of energy is released when the bond is formed. So it is sometimes it is also called as binding energy, right? The ionic crystals are hard and brittle. They are hard and brittle due to very powerful electrostatic forces between the ions. Considerable energy is required to overcome these forces and break down the bonds, right? Hence they have very high melting and boiling points, right? So due to very powerful electrostatic forces between the ions, we need considerable amount of energy to overcome the forces and break down the bonds, and therefore they have high melting and boiling points. So ionic solids, they have high melting and boiling points. The ionic crystals are soluble in ionizing solvents like water and liquid ammonia, right? They are soluble in water, right? So if we have NaCl or sodium chloride, it can be easily soluble in water. So they are soluble in ionizing solvents or water and ammonia. The ionic solids are good insulators. There is no electric conductivity because the electrons are tightly bound in the field shells of the two atoms involved, right? So you can see the sodium ion has attained the Nobel configuration, and also the chlorine ion has attained the Nobel configuration. That means there are no free electrons, right? So we know that the electricity or electric conductivity is because of the free electrons. If there are no free electrons, there will be no transfer of electrons, or there is no flowing of electron, and therefore there is no current, and therefore they are electrically insulator. They are good insulator, right? However, in ionic crystals there is some charge transport by the charge ions themselves, but we have the charge ions, and now if we dissolve these ionic crystals into water or some other solvents, we can have the charge ions. So sodium plus or chlorine minus ion, they can be attracted towards the positive and negative terminal of the battery, and because of that there may be some charge transfer. But this charge transfer or this current is not due to the electron transport, but it is the transport of charge ions themselves. So we must remember this thing. In other words, the ionic ions are charge carriers, not electrons, as in the case of metals. So in the case of metals, the charge carriers are electrons. Here charge carriers are ions themselves. So since the ionic mobility increases with temperature, so with increase in the temperature, the ions, they can easily move from one place to another place. The electrical conductivity of the ionic solids also increases with temperature, right? So when the temperature will increase, the electrical conductivity of the ionic solids will be also increase, because the ions, that they can easily move with the increase in temperature. Whereas in the case of metals, it was the opposite case. So in the case of metals, what we have, the electrical conductivity decreases with increase in temperature. So temperature is increased, the electrical conductivity will be decreasing in the case of metals. But here in the case of ionic solids, with the increase in temperature, the ionic conductivity will increase, electrical conductivity will increase. So in the today's lecture, we have studied the different types of bonds, and we have also studied the ionic bond in detail. We have studied the formation of sodium chloride molecule, and we have also studied the properties of ionic compounds. In the next lecture, we are going to study the covalent bonds. Thank you.